What's happening, dogs? Mr. Allen here. We're about to simplify these rational expressions, and we're going to list any domain restrictions. Now, with division, it's very similar to multiplication, all right? A lot of similarities, but the domain restrictions, you got to look out for one key difference, okay? So for division here, I can rewrite this as multiplication by flipping my second fraction, right? And then it's just like multiplication, okay? But here's the thing. With domain restrictions, I got to look out for 0 in this denominator. I got to look out for 0 in this denominator. And I got to look out for 0 in this numerator, because if I'm dividing by this guy right here, I can't be dividing by 0. So if this numerator is 0, then this whole fraction is 0, then I'm dividing by 0. That's undefined, right? So 1, 2, 3, all three of those play into my domain restrictions for division. That's the key difference there. All right, same thing though, I can go ahead and factor, and I can flip this guy and rewrite it as multiplication. So first fraction is going to be 7x squared over, and then we got 3 times x squared minus 9. Ooh, that's going to be able to be factored a little bit more, isn't it? But I can also then multiply by the reciprocal here. I'll just rewrite this as 3x minus 9 over 4x squared. Now, I can do a little bit more factoring, so let's do that, right? Let's do that. I'm going to have 7x squared over, and we got 3, and that's going to be x minus 3, x plus 3. Boom. Beautiful. Times, and this guy's going to be 3, and then we're going to have x minus 3, and the 4x squared will remain 4x squared. Okay, so as I stated before, these two and that one right there all play into my domain restrictions, right? So it's going to be 3, negative 3, 0, and, well, 3 again. So no big deal, all right? So let's remember those for the end of the problem. Now I can just go ahead and cancel. These guys are going to cancel right here. Boom, boom, right? X squareds can cancel. And actually, these 3's can cancel right there. Beautiful. So now I have 7 in my numerator divided by, and I just have x plus 3 times 4. So let's go with 4 times x plus 3. Sometimes people multiply it out, so you'd have 4x plus 12 in your denominator. I'm going to leave it like that because I don't see the point. If it's multiple choice, you might see 7 over 4x plus 12. All right? So where x cannot equal, what do we say here? It's going to be 3, negative 3, and we had 0 as well, and then that 3 would have happened as well, because that would make this guy 0, but we already listed 3, so we don't need to do it again. That is it. We got our 3 domain restrictions. Again, key difference there, guys. These 3 spots cannot be 0, because I'd be dividing by 0 here, I'd be dividing by 0 here, and if this is 0, then I'm dividing by 0, right? Okay, there we go. I love it. Let's do another. Let's do another. A little different this time. But once again, x cannot equal 0, z cannot equal 0, y can't equal 0, and x still can't equal 0, and y can't equal 0 up here, but that's repetitive, right? So all 3 variables cannot equal 0. That'll be easy to remember. So let's see here. Let's rewrite it as multiplication. So I'm going to have 5xy z to the 4th over 3xz times, and then I got 12y over 10x squared y. Awesome. All right. Now with these, I like to look for any simplifications with my numbers, and then my variables I like to put together before I simplify. Otherwise, I tend to miss things or make mistakes. So 10 and 5 can be reduced. That's going to become a 2. 3 and 12, that'll become a 4, right? Now, not too bad to put that one together and see 60 divided by 30 is going to be 2. But sometimes those numbers get pretty big, so I like to simplify them like that. If you don't want to do that, I don't care, man. I'm doing it. It's my video. All right, so now I have 4. And then we have x, there's no other x's here. We got y times y, that's y squared. And then I got z to the 4th over. And then down here I've got 2. I don't know why I didn't simplify that before. We'll do that now in a little bit. Sorry, I don't know what I was thinking. All right, I got x, and x squared gives me x cubed. And then I've got y, and I've got z. All right, so I should have just done that. I'm sorry. We're going to have 2 here. So we got 2 in my numerator. Then I've got x to the 1st and x cubed. That's going to give me x squared in my denominator. 3 minus 1 is 2. Then I got 2 minus 1 is just 1, so y goes up in the numerator. And I got z to the 4th over z, so that's going to be z to the 3rd in my numerator. Beautiful. Fantastic. And we said where x cannot equal 0, y does not equal 0, and z does not equal 0. Whoop! Fantastic. Let's circle that bad boy. Let's circle it up. Final answer. 2 dope answers, 2 dope problems. And that's awesome. And America, see you later.